Hey, it's Mr. P Helps with Algebra. This is Unit 4, Topic 2, Lesson number 1. And we're going to start off with finding key features of quadratic functions. And we're going to start by finding the vertex. The vertex is always the point of a parabola that is either the highest point or the lowest point. It's in the middle. And you know that because if I make a line of symmetry that goes through the middle of the vertex, right there, the equation for that line of symmetry would be x equals 0, because every point on this line of symmetry has a x of 0. All right, so the vertex always is on the line of symmetry because it's always in the middle. Determine whether it has a maximum or minimum. It has a minimum in this case, and the reason why it has a minimum is because it has a lowest point, because quadratic functions either go endlessly up or endlessly down. In this case, there is no highest point because it's going infinitely up, but it does have a lowest point, so it has a minimum. Write an equation for the line of symmetry. Oh, I already did that. Let's go to question number 2. Line of symmetry is right here, so that's at x equals 4. There's the vertice right there. This one also has a minimum. All right, next question. There is the vertex right there. The line of symmetry is at x equals -1. And this one also has a minimum. So all of these functions all have minimums, but sometimes parabolas can actually go down, which we'll see in later on, and which means that it actually has a maximum because it goes endlessly down. So the range can be infinitely down, but it just can't go up. It has a highest point. Okay, so in this lesson, this is basically an exploration lesson where you're going to be finding out, this is vertex form, so we've already done standard form. Standard form of a quadratic equation would be ax squared, okay, here we go, try that again. Standard form, so ax squared plus bx plus c. So a would always be the coefficient of the x squared, b would always be the coefficient of x, and c would always be the number by itself, otherwise known as the constant. So this is what we call standard form. But what we're introducing today is something else called vertex form. And vertex form, as you're going to find out, is very good at finding the vertex, which is good for graphing. If we know that the vertex is, then we can be able to graph it without using a graphing calculator. All right, so we got these 3 letters. We've got A, we've got H, and we've got K. And we're going to be exploring about what do each of those letters do when you put it into a graphing calculator. So what I do is I would put this in a graphing calculator and then explore with all the rest of these. Now notice that A is the same. Notice that H is the same. The only thing that changed was K. And when you do this graphing assignment, you will notice that this equation, which looks kind of like this to begin with, ends up turning into this, and then it ends up turning into this. Now, they're all the exact same shape of parabola, but the only difference is that they're sliding up and down. K makes the function move up and down. So that's what we learned. That's what we figured out. So then we want to explore H. So now all of these functions, when you graph them, the first one ends up looking like this. The second one's going to end up looking like this. Oops, I kind of missed that. It should have been here on the x-axis. The vertices should have been right there. And then the last one should have looked something like this. Now, what you notice is that all of these have exactly the same shape because they all have the same number in front. But the only difference is the fact that, well, first of all, they're not moving up and down because there is no k. They're just moving left to right. So k determines if it moves up or down. So we call that translating, which is moving or sliding. H makes it move left and right. Now, there is a key here. The issue here is the fact that it's the opposite of what you would normally think. And there's a reason for that, because it's x minus h. So if h is 1, it would be x minus 1, because h is a positive. So whenever it's subtraction, it actually moves the function to the right, because h is positive, and it's x minus a positive. But if h is a negative, then it would be x plus 1. So if h is -1, that means it moves to the left 1. So I know that seems different than what you would normally think, because x plus 1 you would think it goes right, but it actually goes to the left. And it's going to be the same when we get to other functions. When we get to square root functions and cubic root functions and absolute value functions. They run under the exact same rules. All right, so then we're going to explore A. Now, A is the only letter that actually does more than one thing. When you graph the first equation, we know it's going to be 1 to the right, and we know it's going to be 1 up. So the vertex is going to be 1 right and 1 up. So I'll just put that right there at 1, 1. I'll even label that so you can see. Then we know it has, well, you don't know yet, but then it has an a of 2, which will look something like this. And then what happens on the next one is then the graph looks like this. So when you change a from 2 to 5, it actually makes it skinnier. And there's a reason for that. Because if this is the vertex, when a is 2, that means the next term is 2 above. And the previous term is also 2 above. So it would look something like that. But when a is 5, that means you start the vertex. It means the next number is 5 above, which makes it much narrower. And the previous term is also 5 above, which makes the parabola seem narrower. So basically, the bigger the a, the larger the number, the narrower the graph is going to be. All right, so what do you do when it's a fraction? When it's a fraction like this, that means for every one right, it's only going up a half, which is going to make the parabola wider. So the smaller the decimal, if a is a decimal, then the wider it's going to be. All right, so when you look at this last one, that means it's going to be wide. The fact that it's negative, which is the other thing that a does. So if this is 1/2, so if that is the third equation, then the fourth one would be the exact mirror image, only going down. Because when a is a negative, that makes the function turn upside down. When it's positive, it faces up, it opens up. When it's negative, it faces down. All right, so that's the rules for a, h, and k. As you can clearly see right here, k moves down, h moves it left to right. So a does two things. It determines whether or not it's open up or down, but it also determines if it's narrow or wide. All right, so those are your rules. So if I was going to do some practice here, I can easily graph this equation without using a graphing calculator. I know the vertex. I know the vertex is at 4, 5. And I know the vertex 4, 5. Remember, like I said before, the inside of the parentheses is always the opposite of what you would think. So that's actually 4 to the right, 1, 2, 3, 4, and 5 up. 1, 2, 3, 4, 5. And then the a term is 3, so that means the next term is going to be 3 above, and the previous term is also 3 above. Now, remember, you can't just assume that it's going to be going up 3 each time. So you can't say the next one's 3 above. In fact, you know it's not, because it's going to have a second difference. So if the first one's 3 above, then the next one's going to be more than 3. We don't know exactly what it's going to be, but we do know it's going to be more than 3. It could be 6, it could be 7, it could be 8, it could be 9. It could be a lot of things. We just know it can't be 3. All right, so what if we have this one? So where's the vertex? So this means left 4, 1, 2, 3, 4, and that means down 2. So there's the vertex right there. That's left 4, down 2, and then it's going to be facing downwards because that's negative. That means that every term next to it is going to be half as big. Now, I kind of missed that a little bit. It's going to be a little bit wide. It's going to look something like that. All right, so there's some practice doing that. Opens. This question opens upwards. I'm not gonna write it because I am at 8 minutes already. The vertex would be at 2, 6 because remember it's always the opposite. The translation, well, that basically means that it moves right 2, up 6. This one has a minimum because this one is opening upwards, and I know that because a is a positive, which means it has a minimum value. Now the line of symmetry would always be the same as the x term. So the line of symmetry is x equals 2. I looked right there. That's always going to be the same thing. Increasing interval and decreasing interval. So think of a function moving from left to right. So it goes this way. So it's decreasing when x is less than 2. And then it's oh, wait. Did I do that backwards? I'm sorry. Hold on. Let me go back. I did that backwards. So it's increasing when x is greater than 2 because you can see right here it's going up. So when x is greater than 2, and it was decreasing in the beginning. So it went down and back up. So it's decreasing when x is less than 2. All right. I know I have another one there, but I do want to get to the homework. So that was the same as before. All right. So a table of values for f of x is x squared is given below. So first thing I want to do is I want to find the vertex. The vertex is right here, and I know that because these two numbers are the same, these two numbers are the same, and so are these two numbers. So I'm going to start with the vertex right there. I could graph the points. We've got 1, 1. It's the same on the other side. 2, 4. 1, 2, 3, 4. Same on the other side. And then 3, 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Whoop, did I miscount? So I guess it's one above right there. Okay, so there's my parabola. That's kind of what it looks like. All right, so I've graphed that. Number 4, Compare the values of the table g of x and f of x. Identify the same. Identify what stays the same and what changes. Use this information. Okay, so this is x squared right here. So we call that our parent function. And the reason why that's our parent function is because that's the most basic thing. That's every function is going to come from that. So sort of like you came from your parents, these functions are going to come from that. We're going to talk about how they're translated. How did they move? So let's find the vertex again. Okay, that's easy. There's the vertex right there. 0, -7, 1, 2, 3, 4, 5, 6, 7 right there. 1, -6 means it's going to be right there. 2, -3, 1, 2, 3 right there. All right, so it's going to look something like that. Now, what makes this different than this one up here is that it's been moved down 7. Okay, it moved down. It literally slid down. It didn't move left or right. It only slid down. It does happen to have the same shape because the next point was 1 above, so A is 1 for both of them. As you can clearly see, it's right there. A is 1. A is 1 with this one either, because it was 1x squared. All right, and last but not least, 0, 2 would be up there. 1, 3 would be there. Okay, so it looks like A is 1 again. 2, 6. 1, 2, 3, 4, 5, 6. Be right there. Okay, so the only thing that has changed here, it's still left or right, nothing. It still has an A of 1, but the only difference this time is that it's moved up 2. All right, it looks like we've finished. Please give it a like if it helped you learn something, or subscribe if you haven't done so already. Thanks again for watching, and look out for more videos in the future. Have a great day.